Okay, so the solution to this infamous problem of how we were able to determine the moon's gravity simply by using golf clubs to drive a golf ball and seeing how far it went on the moon versus how far it went on the Earth. Needless to say, I think this is an incredibly cool problem. So here's the thing. On Earth, this golfer, this astronaut, was able to shoot this ball 32 meters, right? But on the moon, he was able to get a maximum range of 180 meters, okay? Now, it says that the swing, the launch angle, and so on were exactly the same in both locations. So the first thing we need to know is what was the actual speed that he was launching the ball on Earth? We'll never be able to solve the problem for the moon unless we know exactly how fast, what launch speed he was hitting it on the Earth, okay? So let's do a laundry list on Earth to find out our initial velocity, okay? So we're going to start there. So I'm going to say that x dimension, y dimension, set that guy up. We have v1x, v2x, ax, dx, and t, right? Then we have v1y, v2y, ay, dy, and t. Okay? And so we know that the x component, so basically here's a golf launch. Golf ball launch. We have the ball doing its classic parabolic path. And if we want maximum, right, so this is our initial velocity, this is what we're trying to find. If we want the maximum range, this has to be how many degrees? 45, okay? So we know that our v1x is simply going to be v cosine 45. We know that the final x has to be cosine 45 too because it never changes. Ax, the acceleration in x direction, must be 0. And the range on Earth was 32 meters. Okay, so I'm just going to put 32 meters right there. All right, time we don't know yet. We'll probably have to find it out. Okay, all right, so let's do the same thing here. We know that this must be v sine of 45. Okay, and we also know that v2y is going to be the negative version of that because it's launching and landing at the same spot. So this will be negative v sine of 45. Okay, this is obviously negative 9.8, the acceleration in the y direction, right? And dy, again, is going to be 0. Okay, I should point out cosine of 45 is the same as sine of 45, which is just, I have it being 0.71. So these are all just going to be 0.71 v. Same for over here. Okay. Now, let's do what I recommend that we always do. Find time first. All right. I like to use the classic v2 equals v1 plus at. And once again, since this is all the y dimension, I'm going to put little y's here. Y, y, and y. So I know that v2y is negative 0.71 v. v1y is going to be positive 0.71 v, right? A is negative 9.8 t, right? And so if I put all this together, I get a t of 0.144 v, okay? Now I can put that in for both of these, 0.144 v here and 0.144 v over here, okay? Now, as is often the case, once I have t, I can easily solve for stuff over here. And almost always, maybe you guys have seen the pattern so far, I like to use the equation dx equals v1x t plus 1/2 ax t squared. And the reason why I like this is because a is 0, so I automatically know that that goes to 0. Okay? And I know I have my d, so that's just 32, right? I have my v1x, which is, again, 0.71 v. And my t is 0.144 v, right? So then this just becomes something v squared, right? I actually get about 0.1 v squared times 32. And then when I solve for v, I get 17.8 meters per second. Okay? Cool. So I know that my initial launch speed up here on both the moon and the Earth is 7.8 meters per second. All right, cool. Now we can go ahead and solve for the gravity on the moon. Are you ready? I'm sure you are. Okay, erase this guy. I'm going to keep the same guys. And now I'm going to the moon, guys. I'm going to the moon. I really wish there was like moon tourism in quarantine times. I feel like that'd be really cool. Nice little, like if there's a time I was going to go to the moon, I feel like now would be it, because it's definitely not much better here. Okay, so on the moon, we have the same launch, but now, because gravity is so much smaller, it's going to go so much farther. In fact, it's going to go now 180 meters. Okay? All right, let's ask ourselves the same question. What is our v1x? Well, our v1x is going to be, it's going to be the same angle, same launch speed. So this is going to be 17.8 cosine of 45, which I just get 12.7 for that. Okay? So that's 12.7 meters per second. It's got to stay the same, no acceleration in the x direction. That again is 0. And now we're going 180 meters on our drive. Okay? V1y, it's going to be 17.8 sine of 45. Still the same thing, 12.7 meters per second, except this is going to be negative 12.7, right? This we're looking for the moon's gravity. So we'll call that just g, right? And the height, again, is 0. Okay, guys, no big surprise here. Let's do what we always do. We are going to find out first our time. So we do v2y equals v1y plus at. Okay, this is going to be negative 12.7. This is going to be 12.7. This is going to be plus gt, right? I get that this is going to be, well, I don't know yet, is the truth of the matter, right? I don't know what t is at this point. But can I get t? Well, let's see over here. I am going to look over on this side here. And as always, I'm just going to erase this to make a little bit of room. Okay. I am going to use my dx equals v1x t plus 1/2 at squared. Okay. Again, I know that goes to 0. This makes my life really easy. This will be 180, right? This is just 12.7, right? And oh, look at that. I could solve for t quite easily, right? And for t, I get 14.1 seconds. This thing is hovering in the air on the moon for 14.1 seconds. I would love to see that. Okay, now that makes our life much easier because now I can go negative 12.7 equals 12.7 plus g times 14.1, right? I just subtract this over here, divide by 14.1, and I get for g 1.8 meters per second squared. And if you look up the moon's gravity, you're going to find that it's shockingly close to that. So we just used the fact that we know how far we can drive a golf ball on Earth to find the gravity of the moon. And that's really cool. That is the power of physics. And with that, I conclude this week. On the next slide, there's some more areas where you can, a resource where you can practice some of these problems, especially with projectile motion. And yeah, get your fill of those. If you need any more, I'm always available. With that said, I'll see you next week.